Hello everyone. My name is Zuili, and hello everybody in computer security class. Congratulations to everybody to finish the course, and thank you for Dr. Shahid for teaching me the whole semester and try to help me when I have problem. And today I'm discussing about my final project for this class, and this project is divided by two different parts. The first part I will talking about I will talk about designing a location based on service provider, so people can call us LBS. And on the second part, I will talking about implementing privacy to the preserve location privacy. So that means we will have some fake location to increase the privacy level. So for the design part, I I will work on k equal 1. So for the attacker success and privacy, and the attacker success will be 100% because I will give the LBS my real location, so which is k equal 1. So I only give one location to the server, and on k equal 1 it is easy to work on designing the class, and I can see the relationship between the communication costs, and also the and the region of interest. So on the first one, I will work on k equal 1. Firstly, on this problem, on this problem, I have to work on the communication costs. So like we have discussed before, communication costs equal upstream plus downstream, and upstream is equal the amount of file we send to location-based service provider, and downstream means like the number of files the location-based service provider send back to the user. So basically on the second quiz, I work on the distance between me and the location of the base service provider. So I will give a location, and I calculate the distance between my location and the location of the service provider by this. So the distance is equal the square root of 2 of the location of the x location of the base service provider minus my x location plus and and power of 2 plus with y location from my location minus y location from the location based service provider, and power by 2, and take the square root of the sum. I get the distance, and in here I work on the communication cost. So so on the first part, the communication cost will be equal here. Okay, so the communication cost will be equal upstream plus downstream, and the upstream will be equal user location count. So in this problem, I work on the simple thing, which is k equal 1. So user location count will be having a fixed value, which is k equal 1, and the query result is the result from the server. So in here, I will have downstream will be equal len query result. So I go explain why I use length function, because like in here, if I use print query results and I run it, I will see there a whole bunch of result, and the result will be like a lot. So in here will be one location given from the server, and here's another location, and my work is and I have to count how many locations I send back. So that means it is downstream. So that's why I use length function, because it is calculating how many element is having in that list, in the query result list. So okay, so I will delete this thing because I don't need to print. And the cost will be equal downstream plus user location count. So if I scroll down to here, I will have the cost equal communication cost of one query result. So one, because like I explained before, it's a fixed value because I'm working on k equal 1, and that's it for communication cost. So basically communication cost for this problem equal 1, which is my location. I only send one location and I receive whole bunch of location from the query result. And on this problem I'm working on the relationship between the communication cost and the region of interest. So in here we have multiple region. So the region means like the radius between the area, like from me to the LBS, and in here I'm working on from 200 to 3000, and on the on the after working on multiple problem, which is increasing from like 200. Like for example, the first result is on like 200, and the second is from like 45, 100. Like I get like if I work on like if r equal 1000, I will get like communication cost equal 100. So it is increasing. So in here I'm drawing like a chart to show the relationship between the communication cost and the region of interest. So if I run it, I already give the code in here. So if I run it, I will see like if the region of interest is increasing, like from 0 to 3000, the communication cost is also increasing too. So it is increasing like from 0 to 600. So the biggest here we can see like it's 613 communication cost. So will be like 612 file from LBS back to the user, and one file from the user to LBS. So that's it for the design class. So the reason why I work on k equal 1, because it is a simple thing, so we don't have to work on the complicated thing. But like the vulnerable of the design class is containing a really high risk, which is the attacker success for this problem is equal like 100%, because I'm giving my real location. And for the privacy, the attacker success equal 1 divided by k. So like if I'm giving two location, the attacker success is 50%. Three locations, the success for the attacker is like 33%. And if I give four location, it's just only 24%, 25%. And if I'm giving five location, it's giving like 20%. So like the higher of k give me the higher of the safe percent ratio. So I'm working on LBS with privacy. So the idea is same as design class, but I'm increasing the number of k, and also I'm giving the relationship between k and the communication cost. So basically in here I'm working on the user. So for the user, it needs to have the k location. So the location is this a new list. So the list only contain the real location, which is user location. So it is containing only one location. So in here I give a loop because like if I want to add one fake location, the k equal 1, it work on like from 0 to 1. It means I will add one fake location. And if in here k equal 2, I add two fake location. If k equal 3, it's three fake location. So that's why I'm using the loop, because I don't want to repeat the random stuff. Like I'm generating a random location for the fake location, because like for the fake location it doesn't matter if I'm using any location. So it should be like in generating an x and an y, and then after that I can have a k location which is containing both x and y. And after generating, I need to add that location to the real location to mix them together. So I use append, because I'm trying to add the fake location to here, to that list, so it is in the same list. So like in here I have to calculate how many location I have used. Like for example, if I'm using 10 location, it's calculating 10 location, and the query result for this problem is a new list. I create a new list because it is having absolutely nothing right now, and I'm creating a new loop which is from like 0 until from 0 to k, and the query result is extending by the LBS responding. So in here I'm already having the LBS function, which is from here, from that class, so I can use the same function. So in here the reason why I use extend means I'm working on multiple location. So if I'm using 1k, it is like one location from me, but like that's pretty much location from the LBS. So if I'm using two fake location, if I'm using two fake location, I will have something like two respawn from the LBS, and I will get two set of location. So that's why I need to merge all the set together by using extend, so I can put every single location in multiple set to one set, which is query result. And in the communication cost, I still work on downstream and upstream. Upstream equal like user location count, which is k. If I'm using one location, k equal 1. If I'm using two location, which is containing one fake location and one real location, that means k equal 2. And user location count means like upstream cost, and the upstream cost is equal k, because like it is representing how many value of k I'm giving to the LBS. And the communication cost still the same, downstream plus upstream. So the downstream is equal length of the aggregate query count. So the aggregate query count here is the query result. So that means that's a list I have. That's a list contain all the stuff from LBS sent back to the user. So like if I'm requesting the query result for like 10k, for the for the for the 10 for the k equal 10, it still contain all the thing in query result. So everything is containing in here. And when I move on here, I can see I can see my downstream cost is equal the length of the aggregate query result, which is how many location is given from the query result I have generated like before. And we don't have to worry about it because it's query result. I return it as a value. And in here, if I'm generating multiple things, I will. So let's try to run it. And then in here, if I'm working on k, I can see like if I use 1k, the communication cost is 32. That means I'm sending one and the LBS is sending me back 31 location, and maybe like 31 file and 31 stuff. And if k equal 3, the communication cost is 56. So like that means like I'm sending 52. No, I'm sending 3 and I'm getting 53 back. And in here I'm sending 5. I'm getting like 66 back. And in here I'm generating a chart which is showing the relationship between k and the communication cost. So in here we can see is increasing. Like if the k increase, the communication cost is increasing. So so like if we are using fake location, the attacker success is decreasing, but we have to pay more because the communication cost between me and the LBS is increasing because we have to send multiple location and get multiple result. Same as R we have discussed in here. So the more privacy, the more cost it's costing us. So so the more communication cost, the less attacker success. But like like if we are using multiple way of privacy, it costs us pretty much because it needs to lead the attacker to our fake location and our fake result. So it costs us more because we still have to pay for it. So basically that's my final project I'm trying to discuss. So thank you for watching my final project, and I hope you all have a great summer. And I will see you all in the next semester, and hopefully everybody will stay safe from the virus until the end of the pandemic. And thank you so much for listening. And in specific, I really appreciate Dr. Shahid for giving me a lot of opportunity to practice and ask you the question and give and offer your help when I really need help from anybody. So thank you for the successful of this course, and I hope this final project will help us to for the privacy concern. And in the future I will have like different project, we'll work on the bigger thing. So here just the structure of the project. So in the future I will give us the new stuff which is containing more feature, but I just use a structure to make my future project secure. So that's my point now, and thank you so much for listening. and please give me subscribe if it's possible. And thank you. Bye bye.